Hi everyone, today we are going to learn how to divide terms with exponents. So let's see if we can try dividing things with exponents by expanding our terms, and then let's see if we can make a rule to help us find a shortcut to do these types of problems. So if I have x to the fourth divided by x squared, I'm going to expand out the terms in the numerator. So x to the fourth is just x times x times x times x divided by x times x, which is x squared. So we know that with fractions, if you have the same factor on the top and bottom, they cancel out. So you can see what we have left is x times x, which is x squared. Let's try it with part B. So let's expand out y to the seventh. So we're multiplying y by itself 7 times. And then we're going to divide by y cubed, which is y times y times y. Let's start crossing out our common factors, and what we have left is y to the power of 4. Y times y times y times y is y to the power of 4. And last, here, much like when you're multiplying things with exponents, if you're dividing, you notice there's just a coefficient like this where we can simply do division. We're going to do that. So 4 divided by 2 is going to be 2, but let's leave it like this. What if I wrote 4 as 2 times 2, so we can cancel out the common factors? X to the power of 5 is x times x times x times x times x. Y squared is y times y. And then we divide by 2 times x times y. So 1, 2 cancels out, an x cancels out, and a y cancels out. So what I have left is 2x to the fourth y. Now we definitely want to see if we can generalize a rule for this, because it does take a lot of time to expand out your terms and then count how many you have left. So if you look at the problems, for instance, going x to the fourth divided by x squared equals this, and here we have 7th power and 3rd power equals 4, you might notice that all we have to do is subtract the exponents. 4 minus 2 is 2, 7 minus 3 is 4. Here, 5 minus 1 is 4, 2 minus 1 is 1. Remember, if you don't see an exponent, it's a 1. And 4 divided by 2 is just normal number division. So we can use this rule to save us some time. So just to generalize what we just said, the rule for dividing with exponents is if the base is the same, subtract the exponents. And the base will always stay the same. So x to the power of a divided by x to the power of b is just x, same base, to the power of a minus b. We're just going to subtract the exponents. I do want to remind you of a few special exponent rules. First, any base to the power of 0 is always 1. So we're going to remember that. And also, if you have an answer with negative exponents, we're going to make sure we flip it so that term no longer has a negative exponent. We never leave a final answer with a negative exponent. Okay, let's try these three together. So here we have x to the fourth, y to the sixth, z cubed, divided by x cubed, y squared, z cubed. So we're going to go one term at a time. And remember, we're just going to subtract the exponents. So we have an x, a y, and a z term. So for x's, I see it's going to be 4 minus 3. That's these exponents. For y's, it's going to be 6 minus 2. And for z, it's going to be 3 minus 3. So 4 minus 3 is 1. So we can say x to the power of 1. 6 minus 2 is 4. 3 minus 3 is 0. And then just to simplify it, we don't usually write anything to the power of 1. We would just write x. And then we have y to the fourth. And remember, anything to the power of 0 is 1. So it essentially is just going to disappear, because when we multiply by 1, it doesn't do anything. So we have x, y to the fourth. Another way of thinking about that is if you have the exact same number of exponents or powers of z, they're really just going to cancel themselves out in the original problem. Okay, let's try part B. So let's start with just our number division. We have 8 divided by 4, which is 2. And then for our x term, it's going to be 10 minus 2. For our y term, it's going to be 3 minus 1. Remember, when we don't see an exponent, it's a 1. And then for our z term, it's going to be 5 minus 1. So this becomes 2x to the 8th, y squared, z to the power of 4. So it's really important that you don't forget that when you don't see an exponent, it's a 1. If they didn't want you to have a y or a z here, they wouldn't have written it. So you do have to make sure you include it in some way. So it's just being multiplied one time. Okay, let's try this last problem. So here we're going to start with the numbers. So 15 is not divisible by 9. However, 15 over 9 is a fraction that can be simplified. So if I divide the numerator and the denominator there by 3, this becomes 5 over 3. So if you see two numbers that aren't divisible but you can simplify, you need to do that. So 5/3, and then here we have a 1 on top and a 1 on bottom, so you can probably guess that those are going to cancel each other out because it's 1 minus 1, so I'm going to cross it out here. For b, we have 5 minus 6, and for c, we have 2 minus 5. So this becomes 5/3 times a to the power of 0, which is just 1, and then we have b to the power of -1, and then we have c to the power of -3. So here, this one is a little bit tricky because we have some negative exponents left over. So let me rewrite this in a slightly different way. So here, our 5 is in the numerator, and all of these right now are in the numerator. A to the power of 0 is just 1, so it's going to disappear. But then we have b to the power of -1, c to the power of -3, all over 3. Okay, so I'm going to circle the terms that have negative exponents because these need to be flipped to clear the negative. Notice that this 5 doesn't have a negative exponent, so I'm going to leave it where it is. But on the denominator, I'm going to have 3. This b is going to flip to the bottom, and the c term is also going to flip to the bottom. So I have b to the first power and c cubed. And remember, we don't write to the first power. We just write the variable once. So another way of looking at this is if you compare the exponents from the beginning, I notice here that I have more powers on the bottom than on the top. So I know that my final answer will end up with b's in the bottom. Same thing with the c's. I have more powers in the bottom than the top. And if you even think of it like this, you'll notice I have 3 more in the bottom than in the top. That's why I have 3 left over in the bottom. Here I have 1 more in the bottom than the top, so I have 1 left over in the bottom. So if you want to think about it like that and kind of cancel out the common factors in your head, you can do that as well. But just remember, the rule of subtracting the exponents will always work as well. Okay, this is the last part of today's video, so please pause the video and give these 3 a try. We'll check the answer in just a few moments. Okay, let's check our answers here. So for the first one, 6 minus 5 is 1, so you're left with x. 12 minus 1 is 11, so you're left with y to the power of 11. And the z's actually cancel out because it becomes z to the power of 0. So it's x times y to the power of 11. Here, 20 divided by 10 is 2. 9 minus 5 is 4. 7 minus 5 is 2. And 16 minus 9 is 7. And then here, 12 over 8 simplifies to 3 over 2 if you divide both by 4. Then we'll have 1 minus 2, which is -1. 2 minus 8, which is -6. And the 1 minus 1, these cancel out. So you don't have to write it, or you can cancel it out later. And then this is what we have. So we have 2 terms with negative exponents, so both need to be flipped to the denominator. So the 3 stays in the numerator, the 2 stays in the denominator, and then we have a to the power of 1, just a, and then b to the power of 6. Remember, once you flip it, the negative disappears. And also remember, you can tell by the problem. I have more of these in the bottom than the top, which is my answer has them in the bottom and not the top. All right, that's all for today. Thank you so much for watching.